Welcome to this chapter on equilibrium and stability. Equilibrium is the state of rest when all the forces acting on an object cancel out, which means that the net force acting on an object is zero. Now, that is just one of the two conditions for equilibrium. As we can see in this diagram, this person is motionless. That means all the forces acting on him add up to zero. And in this case, there are only two forces. One is his weight acting vertically down, and the second is the normal force acting vertically up. Now, these two forces are equal and opposite. As you can see from the free body diagram, they cancel out, so the net force is zero. This is the first condition for static equilibrium. That is, the net forces acting on an object must be zero. The second condition can be illustrated from this diagram. We see that two equal forces are applied on this object. They are acting in opposite directions, but since they do not act along the same line, they will not cancel out completely. The net force is going to be zero, but this object is going to rotate. Now, that brings about the second condition for static equilibrium, that the net torque acting on the object must also be zero. Now, what is torque? Torque in this case is just the product of one of the forces and the perpendicular distance between them. So there are two conditions for static equilibrium. Number one, the net force acting on an object must be zero. And number two, the net torque acting on the object must be zero. Now, continuing our discussion on torque, you can see from this diagram that if F is the force applied and R is the distance from the axis of rotation, then the torque is the force multiplied by that perpendicular distance between the force and the axis. Now, when you come to this diagram, you see that although the force is the same, the distance, the perpendicular distance is less, so the torque would be less. Now, in this diagram, the distance is the same as here, but the force is less, which once again decreases the torque. So that means torque depends on the magnitude of the force and the magnitude of the distance. But there is a third factor on which the torque acts. Now, if you look at this diagram, you understand that the force is being applied along this line. This is the line of action of the force. And so the perpendicular distance from the axis is this one, which is really small. Now, the extreme case of this would be if the line of action of the force is acting in this way. So, there is actually no perpendicular distance between the line of action of the force and the axis, because the line of action of the force passes through the axis, which means that in this case, there is no torque. The torque is zero. When we look at situations, often as in this case, we have a clockwise torque and a counterclockwise torque. The weight of this child is tending to rotate this seesaw in the clockwise direction. So the clockwise torque would be the weight of this child times F2, while the weight of this child is tending to rotate the seesaw in the counterclockwise direction, and that torque would be the weight of this child times F1. So for static equilibrium, W2 times F2 should be equal to W1 times F1. W2 times R2 is equal to W1 times R1. The second part of this chapter focuses on stability. And as you can see, in the case of this small pencil, there are two forces acting. One is its weight acting vertically down through its center of gravity, and the other is the normal force. And the net force on this pencil is zero, as well as the torque is also zero. So this pencil is in stable equilibrium. Now, if this pencil is tilted a little bit to the left side or displaced slightly, it is not in equilibrium anymore, because we can see that the weight acting through the center of gravity now produces a clockwise torque about the pivot, which is this point, which tends to bring it back to its equilibrium position. This is a case of unstable equilibrium, because we know that if we place the pencil on its point this way, it's never going to stay there. And the reason is, once again, its weight acting through the center of gravity produces a counterclockwise torque which tends to make it fall. That is, the displacement increases and it falls. So this is a case of unstable equilibrium. Now, if the pencil were kept on its side, this is now in neutral equilibrium, because if you displace the pencil perpendicular to its length, it's going to just roll and will again be in equilibrium. So this is a case of neutral equilibrium where every position is an equilibrium position. Same can be said about a sphere kept on a flat surface, as in this case. That's again a case of neutral equilibrium. So there are three cases of equilibrium. One is stable, the second is unstable, and the third is neutral. One last thing which is very important talking about stability is that in order to increase the stability, two things could be done. Number one, the center of gravity could be lowered. As you can see, when this person bends, the center of gravity shifts downward, and so the closer the center of gravity is to the ground, the more stable the object is. A second thing that can be done is to make the base of the object bigger. In this case, if the person spreads his feet apart, the base becomes bigger and becomes more stable. So there are two ways to increase the stability. Number one, increase the size of the base. Number two, bring the center of gravity as close to the ground as possible. These three examples will show that for stability, the vertical line drawn through the center of gravity must lie inside the base. I'm going to draw that. The vertical line drawn through the center of gravity must lie within the base of the object. Now, that is why when a person carries a heavier object, the person leans to one side, and the idea is to make the vertical line through the center of gravity fall within the base. Because the moment that vertical line goes outside the base, the person is going to fall, or the object is going to fall. Now that's again illustrated in this case when the person is carrying some heavy books. You can see the stance is shifted. Person is now leaning a little backwards so as to adjust the center of gravity and to make it once again such a way that the vertical line through the center of gravity falls within the base. That's very important to know for stability.